So hello guys, welcome to another class of this phenomenal physics series. So we were discussing about vectors. We had already learned about the difference between vectors and scalars, and we have already studied that what is a vector, its mathematical representation, notations in the previous class, right? So right now we'll go ahead with now that you have learned what is a vector, how to operate with it. You all know multiplication, addition, subtraction, division in terms of real numbers, right? Even algebra, you have seen variables are there, a by b, and all those things you have already learned. How to do those sort of operations with vectors, we'll learn that today. Okay, so first of all, you have to know certain things. That a scalar, suppose when you multiply a scalar with a scalar, what do you get? A scalar quantity, right? How's it? 2 into 3, it gives you 6, right? Very nice. What happens when you multiply a scalar with a vector? You get a vector quantity. How? 2 and I cap. It gives you what? A vector 2 I cap. It is a vector quantity, right? 2 is a scalar number, I cap is a vector quantity. It gives you 2 I cap. Correct? 5 times some vector a. It will give you 5a. 5a is another vector whose magnitude is 5 times that of magnitude of a vector. Correct? So scalar into a scalar gives you a scalar. Scalar into a vector gives you a vector quantity. Now what can vector into vector give you? What is this multiplying of vectors? So whenever you say multiplication of vectors, multiply vectors, there are generally two types of multiplication. Now this is very interesting. Generally you have seen in real numbers, correct? There is only one sort of multiplication. Number of times, that is called multiplying. 2 into 3, how many times you are adding up? 3, right? That is 2 times of 3 or 3 times of 2, that you get 6. But what is the concept of multiplication in vectors? There are actually two types of multiplication: dot product and cross product. So we'll go ahead to learn with these things. Okay, so first of all we'll start with the very basic operation of addition. Correct? So addition scalar added with a scalar, what is it? Tell me. 2 plus 4, 6 is a scalar quantity. What is a scalar plus a vector? 2. Here you take any vector. 5i cap plus 3j cap plus. Correct? Scalar plus a vector. Anything you can attempt? It has no meaning. It has right now no meaning, because 2 in which direction we still don't know. Okay, can't simply add a scalar to a vector without specifying, because we don't know this 2 is in which direction, which coordinate, right? That has actually no meaning. Now what about addition of vectors? What about vector plus a vector? It will give you a vector quantity. How? So a1i plus b1j plus c1k cap is one vector. You are adding with a2i cap plus b2j cap plus c2k cap. When you add these two, the individual components will get added. Like only the I component will get added together. Okay, magnitude along j will get added together. Components. So b1, b2 are called the components along y or the j direction. plus c1 plus c2 k cap. Okay, so this is the final thing that you are getting. What is this? This is also a vector, since it has some magnitude, square root of a1 plus a2 square plus b1 plus b2 square plus c1 plus c2 square, right? And direction also, it has all the unit vectors, correct? So vector plus a vector, you are getting another vector, right? So this is addition in the Cartesian coordinate. How to know it graphically? That suppose on a piece of paper or on a plane, on a reference frame, suppose vectors are given, right? How to denote a vector, you already know, right? Suppose this is vector, a vector, and another vector you have to draw. Suppose in this plane there is another vector, b vector. So these two are vectors. What is a plus b? What is a vector plus b vector? That is the question. Graphically, what is the meaning of it? So what we have to do is we have to translate this parallelly. Parallelly translate this without changing its angle or anything. We just parallelly translate it. Okay? Draw it parallelly. Oh, sorry. So draw it parallelly. Correct, no? This is parallel to this. Parallelly, you shift the vector so that its tip, also starting point, or the tail of the arrow matches with tail of the other vector. Correct? So parallel translation you do, so that now they have one common tail. Let this be O. Okay? So now this also is B vector, because why? When you parallelly translate a vector, it remains the same, because we know opposite sides of a parallelogram are equal in magnitude, because the length of the arrows are same, correct? And also it is pointing in the same direction since it's parallel. Hence, whenever you are parallelly translating a vector, the vector remains same both in magnitude as well as in direction. So it is equal vector. It is same vector. Okay, now what about addition? So now we have brought the tail of the two vectors close to each other, and it is at the same point O. So A plus B will be given by, so we'll complete this parallelogram with A vector and B vector as two of its adjacent sides. Okay, so this line will be, let me name it A, B, C. OABC should be a parallelogram. This is parallel to this, this is parallel to this. So when you complete this parallelogram, the diagonal of the parallelogram, this diagonal will represent A vector plus B vector. Okay, understood it? So parallelly translate it to meet the tail, so that the tail of the two vectors is common. Then complete the parallelogram with the two vectors as adjacent sides, and then the diagonal of the parallelogram will be the addition of the two vectors. Whatever is the length, that will be the magnitude of the resulting vector. So A vector plus V vector is the, it is also called the resultant vector. Resultant vector. So this is also known as the parallelogram law of addition. Okay, may sound very complex, but it isn't. Okay, just what you have to do, again repeat with me, parallelly shift one of the vectors to the other vector till their tails coincide. Once their tail coincides, you have to make a parallelogram with the two vectors, A vector and B vector, as adjacent sides, you have to make one parallelogram OABC over here. After that is completed, you have to draw the parallelogram diagonal through O, that is their common tail. Whatever diagonal you will be getting, that will be the resultant vector, correct, pointing from O to the farthest point B, and the magnitude of O, length of OB will be the magnitude of the resultant vector A plus B, correct now? So another way of seeing this addition, we'll go through another way of seeing this addition, that is the triangular method. So suppose on a plane, this is one vector, this is another vector. You are told to add it. So suppose this is A vector, this is B vector. You are told to add it. So you parallel shift it. Now you will not shift the tail to the tail. You shift the tail of one vector to the head of the other vector. Okay? Parallelly translate it. You parallelly translate this also. Okay? So this becomes, when you parallelly translate a vector, the vector remains equal or same, because neither its magnitude is changing nor its direction is changing. Okay, so parallelly you have translated this vector now to the tip. Previously in parallelogram law of addition, what we had done, we had shifted the tail to the tail. Now from the tail to the head. Tail, this is called tail. Are you understanding now? This is called head. So we have shifted the tail of one vector to the head of another vector. Now what will be the resultant? Resultant will be from the tail of the first vector to the head of the last vector. Whatever vector you will get, that is our A vector plus B vector. So it will point from what? From tail of the first vector to the head of the last vector. What is first last means? First means whichever tail is free. So from the free tail to the free head. Correct. This is the free tail. Free tail. A vector has a free tail, but it does not have a free head. Its head is coinciding with the tail of B vector. Similarly, B does not have a free tail. It has a free head. Head or an open head. Whatever you like to call it. So O, A, B. Okay, so two vectors, A vector, B vector, lined one after the another. Okay, so the resultant vector, the resultant of these two vectors, A vector plus B vector, will be given as the vector joining the free tail to the free head, or tail of one vector to the head of the other vector. Correct? And this isn't this will converge with the solution of the parallelogram law also, because over here you can see that OC is B vector. What will be vector AB? Come on, tell me. Vector AB will be the same as B vector, because OABC is also a parallelogram. Means OC and AB are parallel and equal in length. Therefore, vector OC is B vector. Similarly, vector AB will also be B vector. Correct. So from parallelogram law of addition only, this triangular law will come. If you concentrate on triangle OAB, you will be able to see that OA is A vector, AB is B vector. What is the resultant? A vector plus B vector is vector OB, which we were talking about over here. Correct. So it comes from the parallelogram law of addition only. It's not a separate theorem or separate technique of addition. Just that two ways you can view it. Once you are translating the vector so that the tail coincides. In the second way, you are translating the tail of one vector to the head of the other. And then you are joining the free tail to the free head. Simple. to get the resultant. So whenever you hear the term resultant of two vectors, nobody will tell you the sum of two vectors. It is generally not used in physics. In physics, whenever 2 or 3 or 5 or 6, you can keep on adding, right? Resultant of two vectors, it always means their sum. Okay, it is always a plus b. Now what did I mean by 2, 3, 4 many vectors? So suppose this paper is a plane. Over here there are many vectors, a1, a2, a3, a4, correct? So suppose you are told to add all these things. So this is a1 vector, this is a2 vector, this is a3 vector, a4 vector. Over here, actually, if you think in terms of the second way, it will be very helpful. Why? Because you can line up one after the another. The consecutiveness will help you. Okay, so you translate all these things so that the tail of one vector meets the head of the previous vector. So we translate each of these things. Okay, so everything we translate. Suppose this is a1, we translate and bring a2 like this, translate and bring a3 like this, translate and bring a4 like this. Okay, not exact length of a4 I am getting, but you just think, means we are parallelly translating these vectors so that the vectors remain same in direction as well as magnitude. a1 vector, a2 vector, you just line up one after the another, right? So many vectors, you just keep on piling head to tail, head of one, tail of other, right? Head of a1, tail of a2, head of a2 meeting with tail of a3, head of a3 meeting with tail of a4. So you make a series like this. Once it is done, now this can go on. I have done only with 4 vectors, it can go on. So once you have done, so what is the resultant of it? It will be from here to here. This will be a1 plus a2 plus a3 plus a4. The resultant of 4 vectors. This is the resultant. Okay, pointing from the free tail to the free head. Okay. So now we have understood a bit of this addition, right? So then what is subtraction? First of all, you have to understand, subtraction, you have to understand what is multiplying a vector with a negative quantity. I already taught you scalar multiplying with a vector is a vector quantity, right? 2 into a vector will give you 2a vector. What does it mean? That is, magnitude will become 2 times magnitude of a vector, correct? And angle will remain the same, or direction will remain the same. But whenever you are multiplying a negative quantity, suppose minus k, negative real number suppose, and you multiply with any vector, what it does is magnitude will be k times mod of b. Magnitude will scale up as a, but direction will reverse, correct? So if in a coordinate system, suppose this is one vector, a vector, correct, and you multiply it with minus 1, it will become this is minus a vector. It is the mirror image of a vector about the origin. Simple. Just opposite to the direction of a, and magnitude will be with whatever magnitude of the scalar quantity. So only minus a vector means the magnitude of will be the same, is the length from here to here will be the same as length from here to here, right? Same length, but the direction will reverse. Then you multiply with minus 2a, the magnitude will be twice and the direction will be reverse. Okay, so right now we know that multiplying a negative scalar negative number or a negative real number with a vector quantity magnifies its magnitude by the same number as the magnitude of the scalar, and also reverses the direction of the vector quantity. Okay, so minus k into b vector, magnitude will become k times magnitude of b vector, and direction will be exactly opposite of that of the direction of b vector. Okay, so now it will be easy to understand what is this subtraction. So suppose I will show you vectors which after translating only. Okay, it can be anywhere in space and you can translate vectors to bring it one after the another, right? We already know that. So suppose these are two vectors which I have brought one after the another after translation. So if I am told to do a minus b vector, a vector, what is a minus b? How to do it? If this is b vector, and what is minus b? Minus b will be opposite to this direction, same magnitude, a vector of same magnitude. Okay, so O, A, B, B1. Correct. So A, B1 is the minus B vector. So O, B1 vector will be what? A vector plus, when you go from the tip of, from the free tail to the free head, what we get? We get the resultant of two vectors. What are the two vectors? A vector and, what are the two vectors? A vector and minus B vector, which is A vector minus B vector. Understood? A vector minus B vector. It's done. So now, instead of using for subtraction, when you want to do subtraction of two vectors, it's better to put in the first way that we learned, that is coincide the tails, not put it one after the another. I'll show you why. Okay, because I translate this AB vector. Okay, it translated to here, suppose. Correct? This also is B vector. PP1, suppose this point is C. Name it as C. OC vector is also B vector, right? OA is A vector, OB is B vector. Now we have drawn OA and OC as the tails are coinciding, which we drew during proof of the parallelogram law of addition, right? From here, if we have to see what is A minus B vector, it will be this vector. See, since it's now AC vector will be the same as OB1 vector. OB1 vector is what? A minus B vector, resultant of A vector and minus B vector. AC vector, because of parallelism, we know parallel vectors having same magnitude. So AC vector will be A minus B vector. Correct? So if we put, for subtraction, it is better to put tails coinciding way. What do we mean? How is it better? It is better since, suppose this is one vector, this is another vector. Correct? I name it as A vector, I name it as B vector. If I want B vector minus A vector, after coming in this configuration, B vector minus A vector can be easily got by whichever is on the right hand side or minus, you put the tail of that vector, and whichever is in the front, you put the head on the head of that vector, right? So this head of the resultant vector will coincide with B, tail will coincide with the head of A. Okay, head will coincide with B, tail will coincide with head of A. Then this vector will be B vector minus A vector. Okay, so B minus A means when the tails of B vector and A vector are coinciding, B vector minus A vector is a vector pointing from head of A to head of B. Similarly, A minus B will be a vector pointing from B vector to head of B vector to head of A vector. This will be A minus B. Okay, very simple. If you put it, for subtraction, it's better to put tails together. Understood? And for addition, it's better to put head to tail configuration. That is, putting adjacent vectors one after the another. Okay, so this is addition and subtraction for you. Remaining, there is this multiplication. This multiplication has many consequences and it will come in huge impact in physics. Okay, so right now we'll just stop over here. You just think about the methods you learned today, go over it, and in the next class we'll learn about multiplication, what actually that dot and cross are, which we were talking about. You just think. Okay, you can read some textbook also before coming. Okay, and also practice the methods, practice some sums on this addition and subtraction of vectors. Correct? Already one sort of multiplication you have already known. These dot and cross are for multiplication of vector with vector, right? Already one sort of multiplication you have already known, that is scalar with a vector, right? That I have already told you over here. K times A vector minus K times B vector. All these things you have already learned now. Vector with a vector is slightly more difficult and it requires a bit more geometrical concept. No need to worry, everything can be learned. Others can learn, you can also learn, right? No need to worry, just keep on practicing whatever we have learned today, the methods of addition, subtraction, what actual minus of a vector means, what addition of a vector means, the parallelogram law of addition, all these things. You just keep on practicing. And okay then, so we'll meet in the next class. If you like the concepts, you like the way of teaching, please give a like. Okay, and please subscribe, it's most important, as you will stay tuned with whenever I'm coming with the next chapter. Even with subscribe you won't be able to get everything, so better you ring the bell icon. Correct? So that will immediately send you a notification of when I'm bringing the next chapter. So what I'm thinking is, once some of these theory portions are over, then we can go ahead with some of the numericals. I'm really very excited to bring on the numerical classes, but for that I have to teach some more of these theories. Okay, so keep on practicing and keep on studying and learning and enjoying physics. Okay, till then, bye bye. We'll meet you in the next class. Stay tuned.